Goddess of Science Physics. I'm Mrs. Bolvin, and today we're going to talk about acceleration, which is the fourth part of our linear motion series. So acceleration is the changing in velocity per unit of time. So the change in velocity per unit of time. Or another way to say it is the rate velocity is changing. But wait a minute. Velocity is the rate distance is covered. Yes, this is one of those weird things in science. It's a rate of a rate. Whoa. Very weird. So you can change the state of motion of an object by changing its speed, changing its direction of motion, or both. Okay, well that makes sense. So that change in velocity, the rate that velocity is changing, can be calculated by this formula here. Acceleration equals the change in velocity divided by the time interval. Now, that's a little bit long to write out every time, so we have a little shortened version for you. So A equals this weird triangle thing V divided by T. Now the weird triangle thing is something that in science we borrowed it from math, because really what they teach you in math is just so you can do your science, in particular do your physics in this course. That little triangle means delta. It stands for change in, and you've probably have seen it if you've seen the slope formula, change in y divided by change in x. So you just subtract two things. So change in velocity. So it's a little easier to write the triangle, the delta, because change in takes a little bit longer. So V is velocity, T is time, and A is acceleration, and it's lowercase a. And make sure that you use lowercase a, because capital A is actually area, so it has to be a lowercase a. Okay, in physics, acceleration is both a slowing down and a speeding up. We have a special word for a decrease in speed per second. It's called deceleration. But deceleration is just a type of acceleration. All speeding up, slowing down, all of that is acceleration. If you want to talk about just slowing down, it's a deceleration. Rarely do I use that term. I usually just talk about a negative acceleration, which is a deceleration. So the brakes of a car can produce large retarding accelerations, which means it's slowing it down. Obviously, that's why we have brakes on our car. Otherwise, we'd be crashing into things all the time. So let's talk about this change in direction. Acceleration also applies to a change in direction. Acceleration is the rate of change in velocity, not the rate of change in speed. Now remember, velocity is a vector quantity, which means direction matters. So if velocity is in the formula for acceleration, velocity is a vector quantity, that means acceleration is a vector quantity as well. So changes in direction affect it as well. So acceleration is vector because it's directional. So whenever you're giving an acceleration, it's really important that you throw the direction on. If something is falling, what's the direction? Well, it's down, okay? So you just write that after the acceleration. Any quantity that has a vector quantity in the formula is a vector quantity. So acceleration has velocity in it. Both acceleration and velocity are vector quantities. When we get to chapter 4 about forces, the formula for force is mass times acceleration. Well, acceleration is a vector quantity, so force is a vector quantity as well. So acceleration is change in velocity or speed per time interval. Acceleration units are speed units per time unit. Whoa. Changing speed without changing direction from 0 kilometers per hour to 10 kilometers per hour in 1 second. The acceleration is in a straight line. There's our math. Now we have this weird unit here that's very, very strange. Kilometers per hour, seconds. Very, very strange. The reason that we have this is because kilometers per hour are the speed unit, and the time unit is seconds. So the acceleration is 10 kilometers per hour. It should be kilometers there. Should be a K right there. Hours, seconds, which reads 10 kilometers per hour second. That's the dumbest unit ever. I never use that. I want to have my time units to be the same because it makes things a little bit easier. And the reason that your book talks about it this way is because it kind of reinforces the idea that the first time unit is part of the speed and the second time unit is the time in which the speed is changing. Usually in our physics class, we're going to measure it in meters per second squared rather than saying meters per second second, which sounds really stupid. We'll just say meters per second squared. Okay, that's it for acceleration for today. Thanks for joining me. Have a great day.